BMAT 205, Chapter 15, Lyryx Lab 15. Bond question. Let us assume that you want to purchase a bond that has a maturity value of $1,000, paid semi-annually, and interest rate is compounded semi-annually. The bond was issued on February 15, 1999. Maturity date is August 15, 2020. Purchase date is February 15th, and the coupon rate is 5% and market rate is 3.75%. The coupon amount is going to be 5% divided by 2 times $1,000 of maturity value. That will be $25 every 6 months. First, in this case, we want to calculate how many payments you are to receive if you purchase this bond and hold until maturity. Easy way, you could use either DBD function on your calculator or just compare that maturity date is August 15th. So from August 15th until August 15th, 2020, from August 15, 2009 would be exactly 11 years. So that's 22 payments plus 1 from February to August will be 23 payments. Or you can use your calculator by putting start date, maturity date divided by 365.25 gives you a number of years, and then multiply by 2 payments per year. You will have your n round to the whole integer, and in this case is 22.99 or 23. And the next step, step 2, we just calculate purchase price on that date. So we have n is equal to 23. Our market rate is 3.75. Payment is 25. Future value $1,000 we are to receive on the maturity date. 2 payments per year, 2 compounding periods, and that gives us 11.15. In example 2, we have exactly the same case, except we're not buying on interest date, but we're buying between interest dates. That is, in this case, we're buying on April 11, 2009. The preceding interest date was February 15, 2009, and the next payment date is going to be August 15, 2009. So the very first thing, we'll do the same way as before, which was the same number. We're going to get 23 payments from the preceding interest date, which is the date before the purchase date. That would be February 15th. And we're looking for total number of payments, 23. That's what we calculate before. Then we find the purchase price of 11.15. Then we go to the second step. In the second step, after we calculate purchase price on the preceding interest date, now we want to go and calculate how many days we have between the last interest date, which was February 15th, and the purchase date, which is April 11. So we find the number of days using DBD function on your calculator. We're going to have 55 days. Then next one, we want to calculate how many days are there between the last interest date and the next interest date. So the last interest date was February 15, and the next one is going to be August 15th. Using DBD function, we obtain 181 days. And in step 3, we take the purchase price on the interest date, on the last interest date, and we're going to find future value of that purchase price on April 11. So that means present value times 1 plus 0.0375 divided by 2, which is I, raised to the power of DBD 1 over DBD 2, DBD 1 being 55 days, and DBD 2 being 181 days, and that gives us $1,122.22 on April 11th. So to summarize, we'll do the same thing as before. We'll find purchase price on the preceding interest date, preceding the purchase price date, and then we have to find how many days we have between the last interest date and the purchase date, and that goes into the numerator, and then how many days we have in the current interest period, which is from the last interest date until the next interest date, which is basically roughly 6 months later. So in this case we have 181, and we just use the calculator to find the purchase price. So that's the purchase price for a bond bought or sold between interest dates.